In this video, we're going to talk about the third way that you can solve a system of equations. The first two ways we've already learned about are to solve by graphing and to solve by using substitution. Third way is going to be solve by using elimination. Okay, so if you look at the model and discuss, you're given two different equations, and we want to know, why can you not use substitution on this one? Well, if you look at the two equations, you would say no to substitution because one of the equations does not say x equals or y equals. You're going to notice that these are both actually written in standard form because x and y are on the same side. So elimination gets its name because your job is to try to pick a letter to eliminate or get rid of. It doesn't matter which letter you pick, X or Y, totally your choice. But let's just say if I wanted to get rid of a 4y, then what would I have to add to 4y to make it become 0y? And that would be a -4. So you're going to notice in order to eliminate a letter, you have to have the same coefficient, but one has to be positive and one has to be negative. Now, sometimes to make that happen, you're going to have to multiply one or both of the equations by a number. So with that being said, let's go scroll and look at our examples. On our first one, choose a letter. So let's say on this one, we choose the letter Y. And in front of Y right now, we have a 3y and a 2y. So what number will 3 and 2 both go into? And hopefully everybody says 3 and 2 will both go into 6. So I need one of the equations to have a positive 6y and the other one to have a negative 6y. So first, let's just turn them into sixes. So I'm going to put a parentheses around each one of these because I'm going to have to multiply each equation by something. On the top one, how do you make 3y become 6y? Well, in order to make that happen, you would have to multiply by 2. And on the bottom equation, to make 2y become 6y, you would have to multiply that by 3. Now, the signs for both of these are positive y and positive y. So they don't cancel out. So that means one of them has to become a negative. So I am going to randomly pick the top one. So I'm going to put a negative with the 2 so that it will cancel out. So on the top, multiply every single term by -2. So like distributive property. So -2 times x is -2x. -2 times 3y is -6y. And -2 times 7 is -14. Now multiply the bottom equation by 3. So 2x times 3 is 6x. 2y times 3 is 6y. Equals 6 times 3 is 18. Now what we're going to do is we're going to add each column. So -2x plus 6x is 4x. -6y and a positive 6y cancel out, which is what we wanted. Yay. And -14 plus 18 is 4. So now you got 4x equals 4. So divide both sides by 4. We come up with our first answer, which is x equals 1. Now, once you have your first answer, then this becomes the same as what it did for substitution. Pick one of the two original equations and go plug in your answer. So I'm going to choose the top one. So here's the top one. X plus 3y equals 7. So now plug our answer for x in. So 1 plus 3y equals 7. Subtract the 1 over. So 7 minus 1 is 6. And then divide by 2. Divide by 3 and you get the answer of 2. So remember, write your final pair as an ordered pair, x, comma, y. So 1, comma 2. All right, on the second one. This time, to be different, let's get rid of x. So in front of x, we have a 2 and a 7. So what will 2 and 7 both go into? Well, 2 and 7 both go into 14. So how do I make the top one become 14? Well, 7 times 2 is 14. And how do I make the bottom one become 14? Well, 2 times 7. Now, when I look at my signs, I'm going to notice right now that they're both positive x's. Okay, so that means one of them has to be a negative. So I'm going to randomly choose, and this time I'm going to choose the bottom one to put the negative with. So on the top, multiply each one by 2, and you get 14x plus 6y equals negative 24. Multiply the bottom one by negative 7, and I get negative 14x minus 35y equals negative 266. Now add your columns. Your x's cancel out, which is what we wanted. Your y's, you get negative 29y equals negative 290. Divide both sides by negative 29, and we come up with our first answer of y equals 10. So now go plug it in. So this time I'm going to choose the bottom one. So 2x plus 5, and instead of y, insert 10 equals 38. So 2x plus 50. Subtract your 50 over. So 2x equals negative 12. Divide both sides by 2, and you get x equal negative 6. Don't forget to write your answer as an ordered pair. So negative 6, comma 10. Now, just like before when we did substitution, you could still run into those two special cases. So let's talk about that. All right, on C, let's say we want to get rid of y. Okay, on y, what will 2 and 4 both go into? Well, the lowest thing that 2 and 4 both go into is 4. So if I want to make the top one say 4y, I would have to multiply it by 2. The bottom one already says 4y, so I don't have to multiply that by anything. But now I check my signs, and they're both positive, so that means I got to have the top one to be a negative so that they'll cancel. So distribute, and you get negative 12x minus 4y equals negative 20. We didn't multiply the bottom one by anything, so leave it alone. 12x plus 4y equals 50. So now add your columns, and you're going to notice my x's also cancel out with my y. So there's nothing on the left side, so that's 0 because everything cancels out. And then negative 20 plus 50 is 30. And since there's no variables left, that means it has to be a special case. So does 30 equal 0? No, that is false. So we would say the answer is no solution. All right, on the next one. Let's say we wanted to cancel out x this time. So 18 and 3. Well, 18 and 3, the lowest thing that they both go into is 18. The top one already says 18, so don't multiply that by anything. The bottom one, to turn that into 18, I would have to multiply it by 6. Now I check my signs. Oops. They're both positives, so that means one of them has to be a negative. So leave the top one alone. Boom, just write it down. Bottom one, multiply each one by negative 6. So negative 18x minus 24y equals negative 60. And when I add my columns, oh, x's cancel. Oh, y's cancel. Oh, plain numbers also cancel. So I get 0 equals 0. Well, that is true. And if it's a true statement, we call it infinitely many solutions, or IMS for short. So please pause the video and go try the next 4 by yourself. Okay, if you had any questions on these 4, make sure you star them so that you can ask me later. And then just like with substitution, we will also have some word problems. So let's look at that next. And a florist is making 2 different types of bouquets. We're making a regular one and a mini one. And then we're using roses and paninis. So let's set it up. Let's say the first one, let's go with the roses. Okay, for the regular, okay, on the regular one, how many roses are they using? Which is 5 x plus the mini, how many roses are they using? 3 y equals, what is the total amount of roses that they are going to be using? 118. So now let's go to the other type. And for the regular, we're using 11. For the mini, we're using 5. And we have a total of 226. So is everybody good that I'm doing X as the regular and Y as the mini? All right, so now we just get to pick a letter to get rid of. So this time, let's say we get rid of a Y. So 3 and 5 will both go into 15. So multiply the top one by 5, the bottom one by 3. But they're both positive, so I need one of them to be negative, so I choose the top one. So that will give me negative 25x minus 15y equals negative 590. The bottom would be 33x plus 15y equals 678. Add your columns, so you get 8x, y's cancel out, equals 88. And if you divide both sides by 8, you get x equal 11. So now go plug that in. I'm going to choose the top one. So 5 times 11 plus 3y equals 118. So 55 plus 3y equals 118. Subtract 55 over, and you get 63. Divide by 3, and you get 21. So we're going to have 11 of the regular size, and we're going to have 21 of the mini size. Okay, pause the video, and you try this one by yourself. Okay, now the bottom 3 questions, they are for you to try on your own as your assignment, and we'll talk about them the next time I see you. Thanks.